Okay, we're going to go ahead and start this lesson on lines, and this should be something you should be really familiar with given what you've done in your previous math classes. So we're going to go through this lesson relatively quickly. Okay, so the first thing we're going to talk about in regards to lines is the slope. So in math, we use the letter M to indicate slope. And our slope formula is going to be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So if we know our line passes through 2 points, x sub 1 comma y sub 1 and x sub 2 comma y sub 2, then we can calculate the slope of the line that contains those 2 points using that formula. And you can think of slope as the ratio of the change in the y directions. That's what y2 minus y1 calculates over the change in the x direction, which is what x2 minus x sub 1 calculates. And typically in math classes, we call the change in the y direction the rise. Okay, so that's the rise in between our 2 points, and the change in the x direction is going to be the run in between our 2 points. So we call slope the ratio of rise over run. Okay, now with slope, like, it doesn't matter what point is your x1 comma y sub 1 and what point is your x sub 2 comma y sub 2, as long as you group x sub 1 and y sub 1 together and x sub 2 and y sub 2 together. Okay, so there are 3 equations for lines that you need to know. Probably the one you're most familiar with is the slope-intercept form. So an equation in slope-intercept form is in the form y is equal to mx plus b, where m indicates slope and the b value is the y-intercept. So really quickly, if you want to sketch a graph, say we have the line y is equal to 2x plus 1. If you want to graph that line in slope-intercept form, the first thing you mark is the y-intercept at 1, and then the graph is going to have a slope of 2, meaning that we can rise 2 and run positive 1. Or the other way you can think of the slope being 2 is to go down 2 units and run to the left 1 unit. So you can write the slope of 2 as 2 over 1, or you can also write it as negative 2 over negative 1. Both of those are going to give you a slope of 2. So the equation of that line is going to look like so. As you move on in math, as you get into pre-calculus next year and in calculus, we start using the point slope formula more frequently. All right, so our point slope formula is going to be y minus y sub 0 is equal to m times x minus x sub 0, where m once again represents slope, and our point x sub 0, y sub 0 is a point that lies on our line. So if we know the slope of our graph and a point that our graph passes through, a lot of times we're going to plug that information into the point slope formula. Now, it's easy for us to go from point slope form to slope intercept form. So let's say, for example, we have an equation in point slope form. Let's say it's like y minus 2 equal to 2 times x plus 3. So that equation is in point slope form. The slope is 2. The point that our graph passes through would be the ordered pair negative 3 comma 2. If we want to write that equation in slope-intercept form, all we would have to do is distribute 2 across both terms on the right-hand side. So we get y minus 2 equal to 2x plus 6. And the last thing that I would do is isolate y by adding 2 to both sides. So that would make y is equal to 2x plus 8. So you can easily take an equation in point slope form and write it in slope intercept form just by distributing on the right hand side and isolating y. Okay, Our third form of a linear equation is called standard form. So in standard form, our equation is of the form ax plus by is equal to c, where a, b, and c are all elements of the set z. So in math, we call the set z the set of integers. Okay, so in standard form, our equation is going to be ax plus by is equal to c, where a, b, and c are all integers. So you can do that one of two ways. So if, let's say we take the equation that we have up above here. If I want to write that in standard form, I can do that one of two ways. I just want to move the x and y terms to one side. So that would be, if I subtract 2x on both sides, negative 2x plus y is equal to 8. Or if you want your x term to be positive, you can multiply both sides by negative 1. And that would give me 2x minus y is equal to negative 8. And either of those would be acceptable for standard form. Okay, so again, an equation in standard form has the x and y terms moved to one side of the equal sign. Okay, now when it comes to lines, we can also look at vertical and horizontal lines. Okay, so vertical lines are always going to be of the form x is equal to some number. Okay, so if I want to graph like the line x is equal to 2, that's going to be the vertical line where no matter what the y value is, the x coordinate of all of those points is going to be equal to 2. Horizontal lines are going to be of the form y is equal to b. So if I wanted to graph like the line y is equal to 1, it doesn't matter what the x coordinate of our point is, the y coordinate is always going to be equal to 1. So graphically, that horizontal line would look like the line in blue. Okay, so let's get into some examples illustrating the things that we talked about at the start of the lesson. So first one says to find the slope of the line passing through the point 6, negative 2 and the point negative 5, 1. So I'm going to call 6, negative 2 my x1, y1, and negative 5, 1 my x sub 2 comma y sub 2. And then our slope here is going to be y2 minus y1 over x2 minus x1. So I'm just plugging those values into the slope formula. So y sub 1 is 1, or sorry, y sub 2 is 1 minus y sub 1, which is negative 2, over x sub 2, which is negative 5, minus x sub 1, which is 6. So 1 minus negative 2 is the same thing as 1 plus 2, which is 3. Negative 5 minus 6 is negative 11. So that slope is going to be equal to negative 3 over 11. Okay, so next example asks us to find the equation of the line with slope 6 passing through the point 3 comma 4, and then we're asked to write the equation in all three forms. So that's slope-intercept form, point-slope form, and standard form. I think the best one to start with here is point-slope form because we're given the slope of a function and the point that it passes through. So for point-slope, we're just going to plug that into our point-slope formula, which is y minus the y-coordinate is equal to the slope times x minus the x-coordinate. Okay, so this is going to be y minus the y-coordinate of our point 4 is equal to the slope 6 times x minus the x-coordinate 3. All right, so that right there is going to be our equation in point-slope form. Okay, next we're going to do slope-intercept form. So if we want the equation in slope-intercept form, we're going to take the equation in point-slope form and then we're going to isolate y. Okay, so when I distribute 6 on the right-hand side, we get y minus 4 equal to 6x minus 18. Then I'm going to add 4 to both sides, and that's going to be y is equal to 6x minus 14. Okay, so again, that slope-intercept form, that's of the form y is equal to mx plus b. And then the last form is standard form. So with standard form, we just want to take the slope-intercept form and move the x and y terms to the same side. So if I subtracted 6x on both sides, that would give me negative 6x plus y is equal to negative 14. If you want to write it like that, that's fine. If you want the x term to be positive, we can multiply both sides by negative 1, and that would make 6x minus y is equal to 14. So I'm okay with either of those two being your standard form. Okay, on to the next example. So the directions for the next one say to find the equation of the horizontal line and vertical line that passes through the point 1, negative 7. Okay, so if we want the horizontal line that passes through that point, horizontal lines are of the form y is equal to some number. And for that line to pass through the point 1, negative 7, y needs to be equal to the y coordinate of that point. So the horizontal line would be y is equal to negative 7. If we want the vertical line that passes through that point, vertical lines are of the form x is equal to some number. So for that line to pass through the point 1 comma negative 7, our line has to be x is equal to 1. That's the only vertical line that's going to pass through that point. Okay, so on to the next one. Next one, the directions say to graph the line y is equal to negative 1/2 x plus 4. Okay, so that equation is in slope-intercept form. So if we want to graph this, we're going to first start by plotting the y-intercept. So the y-intercept is going to be 4. And then the slope is negative 1/2. Now, you can take that slope of negative 1/2 and you can express that slope in one of two ways. You can either write that slope as negative 1 over 2. So I can take that point at 0, 4. If it has a slope of negative 1/2, I can go down 1 and run 2 in the positive x direction, which would put my next point right there at 2 comma 3. Or the other way that we can think of that slope is being 1 divided by negative 2. So I can go from that y-intercept, the rise is 1, so I'm going to go 1 unit up. The run is negative 2, I'm going to go 2 units backwards. So that could put that point there at negative 2 comma 5. Okay, so I can interpret that slope one of two ways. Either as negative 1 divided by 2 or 1 divided by negative 2. And that gives me just additional points on the graph of that line. Okay, on to the next example. So the directions here say to find the equation of the line that passes through the point negative 3, 1 and the point 5 comma 4. And then we're asked to write the equation in slope-intercept form. Okay, so first thing I have to determine here is what is the slope of the line that contains those 2 points. So I'm going to call my first point x sub 1 comma y sub 1. Second point x sub 2 comma y sub 2. And then I'm going to plug that into my slope formula. Okay, which is y2 minus y1, which is going to be 4 minus 1, over x2, which is 5, minus x1, which is negative 3. So we get 4 minus 1, which is equal to 3. over 5 minus negative 3, which is the same thing as 5 plus 3, which is equal to 8. Okay, so once we have the slope, then we can take either of these 2 points here. It does not matter which one we pick. You're going to get the same equation either way. Okay, so I'm going to pick the point, the second point, 5 comma 4. And then I'm going to plug that information into the point slope formula, which again is y minus y naught equal to m times x minus x naught. When you see a sub-zero, that is pronounced not. So y sub 0 is y naught, x sub 0 is x naught. Okay, so this will be y minus 4 equal to 3/8 times the quantity x minus 5. And then that's our equation in the point slope formula. If I want to write it in slope-intercept form, I have to distribute on the right-hand side. So that's going to become 3/8 x minus 15 over 8, and then I'm going to isolate y by adding 4. Now, adding 4 to both sides, if I want that common denominator to be 8, adding 4 is like adding 32 over 8. So that's going to make y equal to 3/8 x. Negative 15 over 8 plus 32 over 8 makes 17 over 8. Okay, so I don't want to make standard form feel left out. So this time the directions ask us to find the slope and y-intercept of 8x plus 4y is equal to 12. Okay, so we have that equation in standard form. Now, I want to tell you this before we even start doing this problem. Okay, if you have an equation in standard form, it is super easy to graph. So all you want to do to find like the graph of an equation in standard form is you can set x equal to 0 and solve for y. So if we do that, we get 4y equal to 12, which makes y equal to 3. So when we set x equal to 0, that made the y value 3. So that gives me my y-intercept. And then we can also set y equal to 0 and solve for x. So we get 8x equal to 12, which makes x equal to 12 over 8, which makes x equal to, both of those are divisible by 4, so that's 3/2. So that's going to be 3/2 comma 0. So that's going to be our x-intercept. And you can easily sketch the graph by just connecting the two intercepts. So you have an x-intercept at 0, 3, or sorry, a y-intercept at 0, 3, and x-intercept at 3/2 comma 0, and then you can connect those 2 points with a line. It gives you a really, really easy way to graph that function in standard form using intercepts. Okay, but question doesn't ask us for that. Question asks us to find the slope and y-intercept of that equation. So all we want to do to find the slope and y-intercept is to take this equation in standard form and write it in slope-intercept form. So to do that, we're going to solve the equation for y. So we're going to subtract 8 on both sides. So we get 4y equal to negative 8x plus 12. And then we can divide both sides by 4. So that's going to make y equal to negative 2x plus 3. So our slope is going to be the coefficient of x, which is negative 2. And then our y-intercept is going to be the b value, which is y is equal to 3. Or if you want to write that as the ordered pair 0, 3, that's fine. Okay, so one more set of things to talk about, and then we'll do a couple of examples with this. We want to define parallel and perpendicular lines. So parallel lines, we say that two lines are parallel if they have the same slope and different y-intercepts. All right, so again, two lines are parallel if they have the same slope and different y-intercepts. And then perpendicular lines, we say that two non-vertical lines, so perpendicular lines are two non-vertical lines such that the product of their slopes is -1. Okay, so again, two lines are perpendicular if the product of their slopes is -1. Another way that you can define perpendicular lines are they are two lines such that their slopes are negative reciprocals. Okay, so if one of your lines has a slope of 2, the line that's perpendicular would have a slope that is the negative reciprocal. So the negative reciprocal of 2 is -1/2. Okay, so let's do two sets of examples with these. So directions ask us to find the equation for the line with the following properties. Okay, so number 1, in part A, we want our line to be parallel to the line y is equal to 1/2 x plus 4 and contains the point 1, -2. Okay, so if our line is going to be parallel to this line, our line has to have the same slope. So the slope of the given line is 1/2. Our line has to have the same slope of 1/2. And then our line also has to pass through the point 1, -2. Okay, so if I plug that information into my point slope formula, that's going to be y minus -2, which is the same thing as y plus 2, is equal to the slope 1/2 times x minus the x coordinate 1. And if the problem doesn't specify like to write that line in slope-intercept form, you can leave it in the point slope formula and that's okay. Again, you guys can very easily go from point slope form to slope-intercept form. If you wanted to go to slope-intercept form, you just have to distribute 1/2 across both terms and then subtract 2 on both sides to isolate y. Okay, part B says it asks us to find the line perpendicular to the line in part A. Okay, so if our line is going to be perpendicular to that line, our line has to have the slope that is the negative reciprocal of 1/2. So the negative reciprocal of 1/2 is going to have a slope of -2. It still passes through the same point 1, -2. So we can plug that information into our point slope formula. It's going to be y plus 2 is equal to the slope -2 times x minus the x coordinate 1. Again, if the question asked you to write that in slope-intercept form, that's really easy to do. You would distribute -2 across both terms on the right and then subtract 2 on both sides. And you could also take that and write it in standard form as well. Okay, just moving the x and y terms to the same side. Okay, last set of examples. So number 2, part A, we want the line parallel to the line x is equal to 5 that contains the point 4, 2. So if we think about the line x is equal to 5, that is a vertical line. So if we want our line parallel to that vertical line that contains the point 4, 2, our parallel line has to be vertical as well. So it has to be an equation of the form x is equal to some number. And if it's going to pass through the point 4, 2, then the x coordinate has to be equal to 4. So that's the line x is equal to 4. In part B, if we want the line perpendicular to the line in part A. So if we have a vertical line, lines that are perpendicular to vertical lines are horizontal lines. So if we want our line to be perpendicular, it has to be a horizontal line that passes through that same point 4, 2. And the equations of horizontal lines are y is equal to some number. So for our line to pass through the point 4, 2, it has to be the line with equation y is equal to 2. Okay, so again, that should be stuff that you guys are really familiar with. So I went through this lesson a little bit quicker just to kind of refresh things for you. So that's it. We'll see you guys in class on Wednesday. Take care.